What's up, y'all? In previous videos, we've looked at the expanding binomials out. We've found the pattern of those, but now we're going to look to find a way that we can get straight in and find any term in any expansion of a binomial using what's called the binomial theorem. Let's get to it. So as I've stated here, this is the key to unlocking any binomial expansion. So if you've got some binomial and it's going out to the nth power, then we have Pascal's coefficient, and we've got a going to the n minus r power, b to the r power. And this is going to produce any term in the binomial expansion given that r is smaller than n and n is a positive integer. In the past, we've done an expansion where we had a plus b to the fifth power. And we saw it first started with Pascal's coefficients. And then we took the a power, or the a value, and we took a to the fifth, a to the fourth, and these things went down in decreasing value. And then we had b, and that started at 0, and it increased in value, in power, until we went all the way up to the fifth power, and we added all of these things together. So now, let's map this out. Here we've got the fifth power, and that matches up with our n value, which is our n for Pascal's coefficient. Now, a lot of times we write this, and I'm just going to lay out all of our Pascal's coefficients here. We write this out using this n choose r notation. So this is going to be 5 for each one of these because that is our n value. And then we saw that the r value was the power of our b exponent. So that was going to be all of these values right here. So that means this would be r would be 0, r would be 1, r would be 2, r would be 3, 4, and 5. And then finally, we have this n minus r power for the a exponent. So that would be all of these powers right here. And how we do that is we take n, which in this case is 5, and we subtract our r, which is 0. So we have 5 minus 1, 5 minus 2, 5 minus 3, and so on. And that's how we get those powers. So now, if we were to expand these out, we could see that all of these pieces are mapped out exactly like our binomial theorem is mapped out here. So now that we've got all of this mapped out, what we can do is we can find a term in the middle of a whole expansion without having to map out this whole expansion. So you might see a problem where you're going out to the 7th power. So here we've got find the coefficient of the x to the 4th term in this expansion. If we take what we just had and we said a plus b to the nth power, and that's going to help us get to n choose r, a to the n minus r, b to the r. So we can actually do this two different ways. First, we know that n equals 7, right? We've got 7 right up here. If we want to figure out where this is in the expansion of all of this, we need to know this value right here. So if n is 7 and our result needs to be 4 because the x term is the a term, the x is in the a position, so the x to the 4th, this result needs to be 4. So if we have 4 equals 7 minus r, well, we can very easily solve for r and see that r is going to be 3. So now we have n is 7, r is 3, and we have Pascal's coefficient. We also have x going to the power of 7 minus 3. And then we have the b term, which is negative 3, and that's going to be to the 3rd power. So what we've just done is instead of having to expand this whole thing out, we've found exactly where we need to go in here. Now, what some people think is, hey, this is negative 3, this is just going to be a minus in front of here. Not necessarily. We have to remember that this negative 3, this would be like saying x plus a negative 3 to the 7th power. So we want to consider b as our whole term of negative 3. So now in terms of all of this, all we have to do is calculate that. So I'm going to start with Pascal's triangle, and I'm going to go to Math. I'm going to arrow over to the PRB, the probability option, and I'm going to choose NCR. And I've got 7, choose 3. and that's going to give me a value of 35. So I now know that this is 35. That's going to be times x to the 7 minus 3, which is the fourth power, and then I've got negative 3 cubed, which is negative 27. When I multiply these two terms together, I'm going to get negative 945 x to the fourth. So that's this whole term multiplied out, and I'm looking for the coefficient in this. So the thing that you want to keep in mind is that this here, this is the coefficient. So if you're being asked to find the coefficient in the term, your answer is negative 945. But if you were asked to find the term, then this whole thing is the term. Sometimes you're asked to find the term, sometimes you're asked to find the coefficient. If you answer a coefficient including the x value or x variable in there, you're not going to get full marks for that. If you're asked to find the term and you don't include the coefficient, which I don't know why you would include the coefficient, so I guess that's not really the issue. The issue is really going to be more if you're being asked for the coefficient. So if you're asked for the term, you write the whole thing down. If you need the coefficient, just the front part, just the coefficient, don't include the x variable. Now we've got one other example where we're going to find the x to the 6 y cubed term in this expansion here to the 9th power. All right, so we already know that n is going to be 9. But now we need to find our r value. What is r going to be? Now we could do like we did in the previous example, and we could say, well, we've got 9 minus r, and that's got to equal some value for our r. I'm not quite sure what it is, but we actually already know what it is. It's right here. This would be like our a term. This would be like our b term. So if we've got if we're looking at this, our b term always carries the r value with us. So if we look here, y is to the third power, so this thing is going to be to the third power. So r is going to be 3. So now we have our Pascal's coefficient. We know that's going to be 9 choose 3. And then we have our a term, which is 3x, and that's going to be to the 6th power. And then we have our last term, our 5y, and that's going to be to the 3rd power. Now as we expand this, we find 9 choose 3 with our calculator. So we're going to go to math, arrow over to probability, NCR, and we're going to have 9 choose 3, and that value is going to be 84. So here we've got 84. Now we've got 3x to the 6th power. Remember, that's 3x times 3x times 3x, so both of these things go to the 6th power. So we're going to have 3 to the 6th power times x to the 6th power. And then same thing here, we're going to have 5 cubed and y cubed. So we're going to have 5 cubed and we're going to have y cubed. All right, so we've got our x to the 6th, y cubed. Now we just need to multiply all this stuff out. 84 times 3 to the 6th is 729 times 5 cubed, 125, x to the 6th, y cubed. Now we just need to multiply all of this together, and that's going to be 7,654,500 x to the 6th, y cubed. And in this case, we're looking for the term. So the whole thing is going to be our solution, and we have answered this one. So those were a couple examples where we've used the binomial theorem to not have to expand a whole binomial, but to get right to the center. If you found that helpful, make sure you give me a like and help spread this video across the YouTube universe. Now, in the next video, what we're going to do is we're going to look at what happens if our terms of our binomial actually combine. So everything that we've looked at so far, we've had an a and a b. We've had a 3x and a 5y. All of these things are not able to merge. But in the next video, we're going to look at what happens if you've got an x and another type of x, and they start to merge together in the binomial expansion. These are my favorite types of questions. So check it out in the next video. I'll see you there.